Determine the support reactions for the given problem. Okay, here what they have given hinge on one side, and other side it is a roller, but it is not a horizontal roller, it is an inclined one, right? So instead of giving this theta angle, what they have given vertical and horizontal. Okay, 1:2 they have given. Okay, so now what we have to do is, first we need to find out this theta, and before that what we need to do is we need to write down what are the reactions that are possible. Here one vertical at A, suppose this is A and this is B, then this is vertical at A and there is one horizontal at A, because what we have hinge here. Hinge means two support reactions will come, whereas here one will come that is normal to the plane. Okay, this is a plane. Okay, this is a plane. To this plane we'll get one normal here, right? So for that, to find out this angle, what we must know what is this angle theta. So first we'll find out the theta, right? So we know tan theta is equals to what? 1/2. Therefore theta is equals to tan inverse of 1/2. How much we get? So we get so tan in theta, we are calculating this theta, right? So this angle we are calculating. So this will be, this I'll call it as reaction at B. Okay, so this theta, so that is tan inverse of 1/2. So we get 26.56 degrees. So if I calculate this one, so it will be like a triangle now. So this is the plane on which the roller is kept, and here we have a support, we have this reaction. So now if I join this is what we have got theta. So this is a triangle, so this will be how much? This will be 90 degrees, because this is normal to the plane, right? So this is 90, this is theta, so this will be how much? Other thing is 90 minus theta. Total it will be how much? 180. In that we have to remove this 90, so we get 90 minus theta. So if I calculate this angle, so let us call this as alpha. So therefore alpha is equals to how much we get? 90 minus theta, that is equals to 90 minus 26.56. So we get 63.43 degrees. So we have got this theta. Okay, so now if I got the theta, so what we can do is, so if I resolve this one into horizontal and vertical, so one horizontal reaction I get. Okay, because this is inclined one, right? So one horizontal reaction I get. So let us call this as horizontal at B, and let us call this as 1 here, so that is vertical at B. Okay, so horizontal at B is equals to RB. This is what this is horizontal, right? Though this angle is with respect to horizontal alpha itself. So what we get? Cos of this alpha is how much? 63.43 degrees. 63.43 degrees. Similarly, VB is equals to RB sine 63.43 degrees. Okay, so now we have these equilibrium equations. First we'll take summation of Fx is equals to 0. Correct? So if I take summation of Fx equals to 0, and now you see what are the horizontal reactions that are possible here or given. One is HA. Okay, so this is in positive direction, I'll take it as plus HA, and here there is one more here, right? So if I resolve this, again I get one horizontal like this and one vertical like this. Correct? So this horizontal is how much? 100. This is in this direction, this is also positive direction, so plus 100. So if I resolve this in horizontal, what I get? 100 cos 45, right? So cos 45, and then any other horizontal. Next come we get one more here, that is minus. Okay, this is in the opposite direction, so that we take it as minus RB cos how much? 63.43 degrees, which is equals to 0, right? So if I rewrite the equation, what I get? HA plus RB cos 63.43. So it is 0.447. Sorry, this is minus RB 0.447 is equals to minus, if I send this to the other side, what I get? Minus 100 cos 45. So cos 45, 100 cos 45. So what I get? 70 point, I'll write it directly, minus 70.71. So let us call this as equation number 1. Let us call this as equation number 1. Now we'll go to the second equilibrium equation that is possible. Okay, so I'll write here second equilibrium equation, that is summation of Fy is equals to 0. So second equilibrium equation, if I take that, so what we get? So what are the vertical forces that are there here? First Va is there, right? And then this 100 is coming down. If I resolve this one, we get vertical direction. Okay, and here this 50 is there, and there is one more Vb, right? So I'll write all these things, Va, okay, plus I'll add this RB sine 63.43 degrees, correct? And then this is in the downward directions, minus 100. So if I write it downward, what I get? 100 sine 45. Resolving this 100, this is also inclined, this is not a horizontal or vertical, right? So and then we have this 50 kilonewton per meter, which is running for a length of about 3 meter. This is 3 meter, okay? So this is also minus 50 into 3, which is equals to 0, right? So if I solve it, what I get? Va plus RB sine 63, how much we get? I'll check it. Sine 63.43. So it is 0.894 is equals to, if I send this to the other side, 100 sine 45, this is also 70.71. This is also plus 150. So we get Va plus 0.894 RB. Va plus 0.894 RB is equals to 220.7N. Let us call this as equation number 2. We have got two equations, and how many unknowns are there? So here one HA is there, one RB is there, and one VA. So 3 unknowns are there, but we have only 2 equations. So solving this is not possible. So what we'll do? We'll go to the third step, third equilibrium equation, that is summation of moment is equals to 0. Summation of moment is equals to 0. So we have third equation, summation of moment is equals to 0. So what we'll do, we'll take moment at a point A only, right? So if I take the moment at point A, so now see, as these two reactions, okay, these two reactions are exactly at point A itself, coinciding at point A itself, so then there will not be any moment created because of these two, right? And this 100, if I resolve into horizontal, so this is also in the direction of this, or it is also it will also coincide with the point A itself, so thereby there will also be no moment generated by this horizontal force, that is resolvent of this 100, and only this 100 vertical, which is there in vertical, that will create some moment, right? So that will consider first one, that will write, and if I consider this vertical, right? So this will create a clockwise moment. So clockwise moment means plus 100 sine 45, because this vertical is 100 sine 45, this is 100 sine 45, and this horizontal is 100 cos 45, right? So this 100 sine 45 will create a clockwise moment, and what is the distance? Distance is 1 meter. So I'll multiply it with 1. Force into distance, that will give us moment. And now for this uniformly distributed load, what I have to do? I have to convert it into a point load. Okay, this is the point load, and what is the intensity? 50 into distance, total distance, 50 into 3, correct? So this is 50 into 3, and this distance, how much is this? This will be 1.5 meter. Total length is 3 meter, half of that is 1.5 meter, right? So now if you write it again, this will also create a clockwise moment. Clockwise moment means plus 50 into 3 is the intensity, and what is the distance? Horizontal perpendicular distance 1.5, 2.5, 3.5 multiplied by 3.5. This is the force and this is the distance. Okay, this is the force into distance. And next, this HB is actually in the line of this. It is also in the same line of this point A only, right? Because if I draw the force here RB, and there will be two reactions, one is here actually and one is here, so I don't want it to mess up here, so that's why I've written here. Okay, don't get confused. So they will also create a same this HB is in same line with the point A only, right? So because this is in same line, so what we get, we don't get any moment because of this HB. Only because of VB we get the moment, right? So that is also which direction, this is anti-clockwise moment it will create, right? So that is minus VB into VB is what? VB I write directly as RB sine 63.43 into distance is how much? Distance from here, distance 3 meter, 4 meter, 5 meter, correct? So 5 is equals to 0. Anything else we have missed? No, right? So after solving, so if I solve it, what I get? RB, right? So RB is equals to, if I solve RB is equals to, I get 133.21 133.21 kilo Newton. So all of you got the same value. Please just check once. And we have got RB here. And if we see this equation, okay, so here unknowns we have 2. You coming back to the equation 2. So if I substitute RB here, what I get? VA, right? So if we see this equation number 1, if I substitute RB here, what I get? HA, because only unknown is now here we have two unknowns, HA and RB, but we have got RB value. If I substitute here, I'll get HA, and here also same. We have two unknowns, VA and RB, and if I substitute RB, what I get? VA, right? So from equation 1 and 2, from equation 1, if I back substitute here RB value, so what I get? RB is equals to VA is equals to HA is equals to, so what I get? HA is equals to minus 11.127 kilonewton, correct? And next from equation 2, okay, so I get VA, substituting back in this equation 2, so I get VA is equals to 101.57 kilo Newton. And as we have got negative sign, what it means? We have assumed HA in which direction? This direction, right? So it is wrong. So whatever assumed is wrong, but answer is correct only. Whatever we have assumed is wrong. So it means HA is equals to 11.127 kilonewton, but it is acting in this direction. What we have assumed here? We have assumed initially it is acting in the right side, but actually what is happening? It is acting in the downward action. Reaction is there in the left side. So now what we'll do? We'll find out the resultant. Okay, so I'll just rub this part. And we'll find out the resultant. So resultant RA, okay, that is RA is equals to square root of HA square plus VA square. Okay, so HA, how much we have got? So you substitute that here, and we get finally reaction at A is equals to, how much we are getting? Okay, 102.18. Correct, it's correct. 102.18 kilo Newton. And similarly we need to find out this this is reaction at A, correct? This is reaction at A, and this angle we need to find out, that is theta A. You can call it as theta A. That theta A is equals to tan inverse of vertical at A divided by horizontal reaction at A. So if I substitute vertical reaction at A, how much we have got? 101.57 divided by, actually here this will not come like this. Why? Because we have got the final resultant horizontal as like this, right? This is what we have got, horizontal at A, right? So now the resultant will be here, something like this. It will come in this direction. Okay, and this is the theta we are going to find out now. So this is theta 101.57 divided by HA, that is 11.127. So we get theta is equals to 83.75 degrees. this is the problem. Here we have a simply supported beam, and to this simply supported beam there is one 5 kilonewton load is applied here, and then there is 10 kilonewton meter is the moment that is applied, which is in anti-clockwise direction. Okay, and there is a uniformly distributed load of 3 meter length, and intensity is 2 kilonewton per meter, and there is also one more uniformly distributed load acting in a horizontal direction at point B or support B. Okay, and its intensity is 3 kilonewton per meter and length is 1 meter. So again, for this, so what we can do is first we'll find out the support reaction for the given problem, and for that first what we'll do is first we'll write on the what are the reactions that are coming here. One is this and one is this. So this is point A. Okay, this is horizontal at A and this is vertical at A. Okay, and there is, as this is only roller, so what we get, one reaction only, that is vertical at B. This is vertical at B. So these are the reactions that we need to find out. Correct? So these are the reactions that we need to find out. First, what we'll do, anyway we have three equilibrium equations, and as you are seeing here, this is one horizontal and there is also one horizontal, right? So first what we'll do is we'll start with the first equation, that is summation of fx equals to 0. If I take summation of fx equals to 0, so what are the forces are there? One is reaction, which is acting in horizontal direction. Okay, and then there is this 3 kilonewton per meter with a intensity of, with a length of how much? 1 meter. So that is 3 into 1 is equals to 0. There is no other horizontal force except this HA and this uniformly distributed load which is acting in a horizontal direction. So now what we get, HA is equals to 3 kilonewton. Okay, if I send this to the other side, so we get HA is equals to 3 kilonewton. So this is first one. So second one, summation of vertical forces is equals to 0. Summation of vertical forces is equals to 0. So if I take summation of vertical forces, so we have one VA here, one VB here, VA and one VB, that is plus VB. There is one VA plus one VB, and this 5 kilonewton is acting in downward direction, minus 5. Okay, and then this 10 kilonewton is a moment, so we'll not consider it here because this is a moment and we are calculating forces, right? So, and this is 2 kilonewton per meter and length of how much? 3 meter. So that is 2 into 3 which is equals to 0. 2 into 3 which is equals to 0, right? So only these many are the vertical forces. One here VA, one VB, one 5 kilonewton, one 2 kilonewton, right? So if I solve here, so what I get, VA plus VB is equals to 3 2s are 6, 6 plus 5 11. Okay, if I send it to the other side, so it will become 11. So let me call this as equation number 1. And next, so I'll come to the third equilibrium equation, summation of moment at A is equals to 0. Summation of moments at A is equals to 0. So this is the third equation. So if you see here, so what we have, so we are, again I am taking the moment at point A itself, right? So if I take the moment at A, so these VA and HA get cancelled. Why we take always that way? So that's if I take here, right? So if I take here, what will happen? So I'll get even you can take at B also, right? So but if I am taking here means I can easily calculate this VB, right? This is the only unknown reaction that will be coming in the equation, right? So here if I take here, this HA and VA get cancelled because there is no moment generated by these two, HA and VA. So next see, this is the 5 kilonewton which is acting in downward direction, that will create a clockwise moment, so 5 into 1, that is 5 into 1, and here this is 10 kilonewton meter is the moment they have given directly, means you have to write it directly. So but it is anti-clockwise means minus 10. And then because of this, first what we need to do, we need to convert this uniformly distributed load into a point load which will act here exactly at the center. So its intensity will be how much? 2 into 3. Its intensity is 2 into 3. And what is the distance? Distance is 1.5 meter. correct? So totally 1.5, 2.5, 3.5, 4.5, correct? So total 4.5, and intensity is how much? 2 into 3. It is also creating a clockwise moment, so it will be plus 2 into 3 into 2 into 3 into how much? Total distance is how much? 1 plus 1.5, 2.5, 3.4, 4.5. That is 4.5. And here we have to consider this moment, this horizontal force also. So here, if I convert this horizontal force into a point load or uniformly distributed load into a point load, so its intensity will be how much? 3 into 1. 3 into 1. But what is the height here? So this height is how much? Half of this, that is 0.5 meter. 0.5 meter. So it is also creating a moment. It is also creating a moment. Which direction it is? So this is creating a anti-clockwise moment. If I take this, so if I take this, it is creating an anti-clockwise moment. So that is minus 3 into 1 into distance is how much? 0.5 meter. 0.5 meter. Okay, and this VB is also creating which moment? Anti-clockwise moment. Minus VB into 3 plus 3, 6 meter. Minus VB into 6, which is equals to 0. Which is equals to 0. Next, so after resolving this equation, so I send VB to the other side. So what I get? VB into 6 is equals to 5 minus 10 plus 6 into 4.5. 6 into 4.5, how much we get? 6 into 4.5 is 27. So it is plus 27 minus, it is 3 into 1, 3 into 0.5, 1.5. So 27 plus 5, 32. 32 minus 11.5 is 20.5. So VB into 6 is equals to 20.5. So VB is equals to 20.5 divided by 6. 3.416 kilo Newton. Okay, so substituting back here in equation 1, from equation 1, so we get VA is equals to what? 11 minus 3.416, 11 minus 3.416, so that will 7.584 kilo Newton. So finally we have got all the reactions. HA we have got here, VA we have got here, and VB we have got here. Okay, we have found all the support reactions. Now what we'll do, we'll calculate the reaction. Wherever we have two forces, there will calculate the reaction. So therefore reaction at A, so reaction at A will come something like this. This is reaction at A, which is equals to, how we calculate? Summation of square root of HA square plus VA square. So if I substitute here HA and VA, so I am getting RA is equals to 8.155 kilo Newton. And similarly we need to find out theta at A. So this is theta, this theta we need to find out. So this theta at A, so theta at A is equals to tan inverse of vertical at A divided by horizontal at A. So if I substitute VA and HA here, so I get 68.42 degrees. 68.42 degrees.